Good morning, sir. My name is P. Gracie. I'm from IT Department Section A. My topic is about symmetric solution to matrix equation with conjugate and transpose unknown and its applications in control. What is a matrix? A set of numbers arranged in rows and columns so as to form a rectangular array. The numbers are called the elements or entries of the matrix. Matrices have wide applications in engineering, physics, economics, and statistics, as well as in various branches of mathematics. For example, A equals to 173. Abstract. We consider the symmetric least squares solutions to a kind of matrix equation with conjugate and transpose unknown by applying of a modified conjugate gradient least squares iterative algorithm, which is called on the MCGLS iterative algorithm. In addition, the convergence analysis of the algorithm is proven. Moreover, two examples are often at the end of this paper for showing the feasible of the MCGLS iterative algorithm. Conjugate matrix. A matrix. A conjugate matrix is a matrix A bar obtained from a given matrix A by taking the complex conjugate of each element of A. Courant and Hilbert 1983. That is Aij whole bar equals to A bar ij. The notation A star is sometimes also used, which can lead to confusion since the symbol is also used to denote the conjugate transpose. Using a matrix X in a similarity transformation, X inverse A X of a given matrix A is also known as conjugating A by X. In this case, B equals to X inverse AX equals to B equals to X inverse AX and A are known as similar matrices. Transpose matrix. The transpose of a matrix is simply a flipped version of the original matrix. We can transpose a matrix by switching its row with its columns. We denote the transpose of matrix A by A transpose. For example, if A equals to 1, 2, 3, 4, 5, 6, then the transpose of A is A transpose equals to 1, 4, 2, 5, 3, 6. Symmetric matrix. In symmetric matrix, square matrix that is equal to its transpose. A is symmetric when A equals to A transpose. Because equal matrices have equal dimensions only, square matrices can be transposed. The entries of a symmetric matrix are symmetric with respect to the main diagonal. So, if Aij denotes the entry in the ith row and jth column, then A is symmetric for every I, j. For all indices I and j, every square diagonal matrix is symmetric since all of diagonal elements are 0. Similarly, in characteristic different from 2, each diagonal element of a skew symmetric matrix must be 0 since each is its own negative. Introduction. The linear matrix equation is very important in control theory and system theory 1, 2, 3. There are many applications in these two fields. At the same time, there exist many dynamical control models such as x into a plus ax into t equals to bu of t and lambda square ax plus lambda bx plus cx equals to 0. For solving the least squares problem of linear matrix equation, many numerical methods appeared. For instance, gradient-based iterative algorithm, least squares QR factorization iterative method, and submatrix constraint iterative algorithm. Based on this effective iterative algorithm, this paper we will construct a modified CGLS iterative algorithm for solving the least squares solution to the following matrix equation with conjugate and transpose unknown. Sigma t to m equals to 1, m to the base m, y n to the base m plus sigma q to n equals to 1, g to the base n y bar h to the base n plus sigma p to k equals to 1, p to the base k, y power t, y transpose q to the base k equals to e. On the whole, we mainly solve the following two problems in this paper. Problem 1. Suppose the known complex matrix satisfied the suitable dimensions m to the base m belongs to c power p into m. N to the base m belongs to c to the power n into q. G to the base n belongs to c power p into m. H to the base n belongs to c power n into q. E belongs to c power p into q. P to the base k belongs to c power p into n. Q to the base k belongs to c power m into q, and m equals to 1, 2, to the n. N equals to 1, 2, and so on k. K equals to 1, 2, and so on p. Find symmetric matrix Y star belongs to c power m into n such that problem 2. If we suppose the solution set of problem 1 DL R Y0 belongs to c power m into n is known symmetric matrix, then we find the matrix Y belongs to L R. Satisfy the following relation. Modulus Y minus Y0 equals to minimum Y belongs to S to the base R belongs to module Y minus Y to the base 0. In this paper, we use the following reminder. Firstly, the so-called CGLS method is presented for solving the solution to the matrix equation with conjugate and transpose unknown in section 2. Secondly, the properties of the presented new algorithm are discussed. Finally, we detail convergence analysis on the presented iterative algorithm has been provided. In section 3, two examples are provided. The conclusion can be put in section 4. Main result. In this part, the modified CGLS iterative algorithm to matrix equation 1, which is called MCGLS iterative algorithm, can be constructed the following form. Algorithm 1. Step 1. Input some known coefficient matrices as seen in the text. So it forms like this. Now coming to the step 3. If modulus R of k equals to 0, then stop. Therefore, you can conclude that y of k is a numerical solution to matrix equation 1. then it can break. Else if modulus of modulus r of k is not equals to 0 and modulus t of k is equals to 0, then y of k is the solution of problem 1. Therefore, it can stop, else k equals to k plus 1. In step 4, calculate v of k. Then we will get u of k plus 1 equals to t of k plus 1 plus lambda of k union of k. Step 5. Go to step 3. Next, we can obtain the following results by means of algorithm 1. Lemma 1. If we can find a positive number u, satisfy the relations modulus t of I is not equals to 0, modulus v of I is not equals to 0, I comma j equals to 1 comma 2 and so on u up to u, I is not equals to j. Then the sequence t of k comma u of k and v of k which are generated by algorithm 1 satisfy the following three relations. I of t, first one, t of I comma t of j is equals to 0. V of I comma v of j equals to 0. U of I comma t of I j equals to 0. By using algorithm 1 and adapting the mathematics induction method, this conclusion can be given for detail. Here, this proof has been omitted. Lemma 2. Suppose S be an inner product space W subset of S and W perpendicular be the orthogonal subspace of W. For a given S, small s belongs to capital S. If we can find W0 belongs to capital W, satisfy modulus S minus WO less than or equals to modulus S minus W, in which W belongs to S. Then it can be concluded that W0 is unique and W0 belongs to W. Is the unique minimization vector in W if and only if S minus W perpendicular to capital S, that is S minus W0 belongs to capital W perpendicular. Here we can see some examples. Example 1. Find the symmetric least norm solutions of matrix equation AYB plus CYTD plus EY bar F equals to G, in which A equals to level 2I, 13 minus 79I, 6 plus 34I, 43 plus 31I, 21 plus 2I, 110, 12, 10, 5 plus 6I, 2 minus 3, 23I, 113 minus 2I, I, 13, 152, 0, 59I. Example B. B equals to 255, 35 minus 152I, 45 plus 65I, 95 plus 85I, 46I, 151, 152, 95 plus 58I, 0, 512, 155, 185, 2I, minus 95I, 125, 118. And we can see so many examples here. At the last, the conclusion is, in this paper, in order to provide the symmetric least squares solutions to a kind of matrix equation 1, the modified CGLS iterative algorithm NCGLS has been proposed. Moreover, by using this MCGLS iterative method for a given matrix XO, the optimal approximation solution has also been stated. Thank you.